Today's lecture is on extensive and intensive property. These concepts are extremely important in the study of chemical engineering thermodynamics. So we are going to learn today what is an extensive property, what is an intensive property, and how to distinguish, how to find which one is an extensive property and which one is an intensive property. So these are my references. Let's go to the next slide. An extensive property is a property which depends on the size and mass of the system. What is the total size of the system? That is important. So if the size increases and the value of the property increases, then it is an extensive property. So if the value of the property, let's say from here to here, if I go to a larger size, then if the value of the property in here and here are different because of the size, then of course it's an extensive property. But if the property remains the same when we go from a smaller size to a larger size or from a larger size to a smaller size, if the value of the property remains same, then it is an intensive property. So intensive property which do not depend on the size and mass of the system, as for example pressure and temperature. If you have a system here, let's say the system here, and if you measure the pressure here, if you measure the temperature here, let's say you're in a room. So these values are, of course, it has certain values. Now, if you just take half of the room, and if you measure the pressure here and the temperature here and the pressure here and the temperature here, of course, these two values are going to remain the same. So therefore, this will be exactly the same value here and here if I divide the room in half. So these are called intensive properties. So let's give some properties how to find out which one is an extensive property and which one is an intensive property. The trick is divide the system in two equal halves with an imaginary partition. The property we are talking about remains same in both partitions, then it is an intensive property. But if the property gets reduced to half, if the property is reduced to half the original value, then it is an extensive property. So if I take this room and make it half, if the value of the properties become half, then of course it's going to be an extensive property. So let's say the total mass of air in this room. If I make a half, of course the mass would be half here, half here. So therefore it's going to be an extensive property. Total volume of the room. So if I make an imaginary partition here, so the volume of course would be divided in half. So this is also going to be an extensive property. But the temperature of the room, of course, even if I make it half, 1/4 or any size, the temperature of the material in the room will remain the same. So it will be an intensive property. The pressure in the room, if I make a half of it, say let's say the room you're sitting in, if you make it half, take half of the room, then the pressure in the room here, let's say this is atmospheric pressure, this would also be an atmospheric pressure, this would also be an atmospheric pressure. So this is going to be an intensive property. Let's say the density of the air in the room. The density of the air in the room, of course, even if you make it half, so the density of air in the room will remain the same, so that will be an intensive property. Specific heat of the air in the room, or whatever the fluid you have in the room, that does not change since you have made it half. So this is going to be an intensive property. Also, there is an important idea here, like if you take the total property but make it per unit mass, then it becomes an intensive property. So let's say you have the total volume of the room, that is an extensive property, because we have seen it becomes half and half here. But if you divide the volume per mass, that means total volume per unit mass of the system, then of course that value, whatever value is here, it will have the same value here and same value here. So total volume of air per unit mass, That means let's say meter cube per kilogram. That of course will be the same value here, here and here. So when you divide that, so it becomes an intensive property. So as you can see, if you take an extensive property and you divide it by mass, then of course it becomes an intensive property. So that is the trick.